Hello and welcome to episode 5 of Why the Universe is Quite Disappointing, Really. You'll notice that I have a change of scenery for this episode. The reason is that I've actually been allowed back into my office at Maynooth University. Unfortunately, I'm only here really to supervise an online exam that's going on at the moment. So I better keep this quick in case there's an emergency that I have to attend to. In the last show, if you could call it that, I talked about galaxies and how they're full of crud, basically, dust and junk. And I want to say something else about galaxies now. Now, if you remember in the last episode, I showed you this picture. That's a picture of M31, the Andromeda Nebula, the nearest big spiral galaxy to our own Milky Way. Now, as I said in the last show, we actually live in a thing pretty much like that. It's roughly the same shape as the Milky Way. And it looks kind of impressive. The light that you see from that image is basically from the stars in the galaxy, and there are lots of stars there. We live not in the very bright central part of our own Milky Way, but in the sort of outskirts, the suburbs, if you like. But it's still a place that you would, if you looked at that Andromeda Nebula, you'd see the bit around the centre, but it's fairly crowded in terms of stars as it appears. So we live in a similar environment to the sort of disk going around the central bulge, as it's called, of a galaxy. Now, I just want to give you a perspective about that. And for that purpose, I've brought this golf ball. It's a golf ball. First of all, I want to make it perfectly clear that I do not play golf, and I do not condone the playing of golf or people committing acts of golf. Anyway, here's a useful prop. This golf ball is about 4 centimeters across. Okay, so what I want you to do is to imagine that this golf ball is our star, the sun. Now, obviously, you have to scale things accordingly. The radius of the sun is 7 times 10 to the 8 meters, and this radius is about 2 centimeters. But just imagine on this scale, if this were the sun, how far away would the nearest star other than the sun be on the same scale? Bear in mind, we're in a fairly crowded part of the galaxy, not the very central part, but in the outskirts where there's still quite a lot of stars. Any idea? I do this in public lectures sometimes, and most people get it wrong. So I'm going to tell you the answer shortly, but just think about it. 10 meters away, on the other side of the road, maybe, outside of campus, maybe on the other side of town. Another golf ball would be the nearest star. So the answer is that the nearest star on this scale to the sun would be 1,100 kilometers away. 1,100 kilometers. That's the distance between Dublin and Geneva, distance between London and Venice, for example. And in between one golf ball in Dublin and another golf ball in Geneva, there's not very much at all. Galaxies are basically very empty. Even the crowded places are empty. One consequence of that is that the Andromeda Nebula, which you can see in the images that I've showed you, is actually very, very, very faint. Although it looks bright, that's in the picture, that's because there's a very long exposure taken to collect all the light from it. It's actually faint because the stars in the galaxies are all spread around. If you could see the Andromeda Nebula in its entirety on the sky, it would be as big as the full moon. But it's too faint. It's too faint to see that. All you can see is a little fuzzy patch in the middle from the very crowded part. Okay, so that's a galaxy. Not much to it, really. Very flimsy and insubstantial. Now let's think about the universe. I'll put this golf ball down. So galaxies themselves have stars in them which are fairly sparsely spread out and not excessively clumped together. And galaxies themselves are enormous distances apart, millions of light years from each other on average. Okay, so that means if you took all the material in all the galaxies in the universe and just spread it out uniformly throughout space, you never get funding for that experiment, incidentally, but suppose you did, it's a thought experiment. If you could do that, you would find that the average density would be less than 1 hydrogen atom per cubic meter. That's very close to a vacuum. It's pretty, you'd be pushed on Earth to make a vacuum that good in any kind of vacuum equipment. So 1 hydrogen atom per cubic meter. Now, when I say that, I'm just talking about the ordinary matter that we know of, stuff that's made of protons, neutrons, and electrons, and so on. There may be some other stuff, which will be the topic of future programs, I guess, but we'll leave that out for now. We'll just talk about the stuff that we're made of, atomic material. And that's a pitifully small amount spread out throughout space. So the universe may be big, but it's really, really empty. There's hardly anything to it. You wonder why it's so necessary to make a universe so big, but put so little effort into providing it with furniture. And we'll say a little bit more about that in the next program.